Welcome to this explainer. Have you ever walked into a massive manufacturing facility and just wondered how on earth do all those giant industrial machines actually communicate their vital signs? Well, today we are diving deep into the invisible nervous system of modern industry, SCADA data logging. It is an absolutely fascinating technology that literally turns raw machine behavior into actionable intelligence. Let's get into it.
Just picture a chaotic industrial plant for a second. You've got hundreds of motors spinning, valves actuating, massive tanks filling up, complex chemical reactions happening all at once. How do these machines actually talk to us? How do they tell engineers what's running smoothly, or more importantly, what's slowly degrading and about to break down? Well, they don't use words, right? They use data. We're talking thousands of I/O points generated by sensors and processed by PLCs every single millisecond. And capturing, storing, and actually making sense of that vast ocean of data is exactly what we're going to decode today.
So, here's our quick agenda for today. First, defining SCADA data logging, then tracking the journey of data, looking at what exactly we log, exploring the applications and benefits, tackling challenges versus solutions, and finally wrapping up with DEVI automation solutions. Okay, let's jump right into section 1, defining SCADA data logging. At its core, SCADA data logging is just the automatic, continuous storage of machine and process information. But honestly, for engineers, it represents something so much bigger. It's the end of data silos. Instead of relying on, say, old-school manual clipboard logging, or just reacting when a red light suddenly flashes on a control panel, data logging transforms these fleeting, real-time events into a permanent, highly searchable digital footprint. By archiving this history in specialized databases, facilities can perform advanced trend analysis, fine-tune their control loops, and basically bring absolute predictability to their automation. Moving right along to section 2, the journey of data. So how does this information actually travel? It follows a really highly structured sequential path from the physical edge up to the supervisory level. It starts right at the source with your sensors, basically the eyes and ears of the plant, collecting raw analog or digital values. Next, the PLC, executing its rapid scan cycle, acts like a local reflex to gather those values. Then comes the critical handoff. The SCADA system pulls this data from the PLC and routes it directly into a specialized historian database, which is custom-built to compress and securely store high-speed time series data. Finally, an operator can query this database to see historical trends, run analytics, and generate their shift reports. Now, to make this whole journey seamless, you need a very precise stack of hardware and software, bridging the gap between the plant floor and IT. Out at the edge, you have your physical sensors and PLCs or RTUs for remote assets. Tying that to the supervisory layer is a robust communication network using industrial protocols like Modbus or OPC UA. Once it hits the server level, the heavy lifting is done by the SCADA software and the historian database to handle all that massive throughput. And finally, to make that data actually readable by humans, we use HMIs, high-performance engineering workstations, and dedicated report servers.
All right, section 3, what do we log?
The real magic of a SCADA system is how it weaves all these different data types together to tell a complete story about plant health. We start with the basics: temperature, pressure, flow rates, tank levels. But the context is what makes it a total game changer. When you combine physical metrics with operational ones, like motor status and pump running hours, engineers can actually spot mechanical wear and tear before it breaks. For example, if a pump is running its usual hours, but the flow rate is slowly dropping over a month, boom, that combination instantly flags a worn impeller. Plus, tracking energy spots inefficiencies while logging alarm history and exact operator actions creates a bulletproof audit trail of who did what and when.
Which brings us to section 4, applications and benefits.
Let's ground this with a real-world scenario. Imagine a municipal water treatment plant. The engineers there rely on continuously logged data, tracking tank levels, pump statuses, and crucial chemical metrics like chlorine dosing. If a pump starts drawing too much power or a reservoir is filling way too slowly, they don't have to guess what's wrong. Without logging, they could be facing a catastrophic citywide pressure drop before anyone even notices. But with SCADA, they simply query the historian, cross-reference motor hours with flow rates, spot the degrading component, and schedule maintenance long before disaster strikes.
And it's not just water treatment. This exact same methodology is the invisible backbone across vastly different sectors. In pharmaceutical and food and beverage plants, data logging is absolutely crucial for strict regulatory compliance, ensuring exact sterilization temperatures and batch traceability. For distributed networks like power grids, solar, or oil and gas, it provides critical remote visibility over massive areas where manual checks are just literally impossible. And in high-speed manufacturing, they use it to optimize throughput and track downtime. It's everywhere. So what's the bottom line here? Proper data logging yields massive dividends. It gives you permanent historical records, which totally transforms troubleshooting. But the holy grail of modern automation is predictive maintenance. By analyzing historical vibration, temperature, and current trends, you can replace a $50 bearing during a scheduled shutdown instead of suffering a $50,000 catastrophic motor failure right in the middle of production. It's a no-brainer. It drastically improves your uptime, ensures compliance, and lets you monitor everything remotely from anywhere in the world.
Let's look at Section 5, Challenges versus Solutions. Now, scaling up all this data collection isn't always smooth sailing. A super common headache is just overwhelming database sizes. The best practice there is implementing something called dead banding, meaning you only log a value when it actually changes by a significant amount, rather than saving identical data every single millisecond. You also have to deal with network latency and communication failures dropping data packets, which means edge buffering and regular backups are mandatory. And when it comes to missing data or bad timestamps across a big facility, you really need careful synchronization of your clocks and proper sampling intervals.
Finally, Section 6, DEVI Automation Solutions.
Look, designing, integrating, and securing these complex data pipelines is seriously tough work. It requires specialized architects who know exactly how to untangle these challenges and bridge that gap between the factory floor and your IT infrastructure. And that is exactly where DEVI Automation Solutions comes in. Their expertise covers custom SCADA solutions, complex PLC programming, and advanced HMI development. They even handle forward-looking tech like AI integrations, IIoT, and smart manufacturing upgrades. Whether you need a control panel built from scratch, a full facility integration, or just technical training for your staff, they've got you covered. You can reach out to them directly at deviautomationsolutions@gmail.com to start optimizing your data architecture today. Which brings us to one final critical question for you to think about. Is your plant's data working for you or against you? Because honestly, without SCADA data logging, you're essentially flying blind, reacting to problems only after they've already caused expensive downtime. But with it, you have the power of complete predictability. Thank you so much for joining me on this explainer today. If you found this technical deep dive helpful, definitely let us know in the comments and subscribe for more breakdowns. Keep learning, keep optimizing, and I'll catch you in the next one.